Hey, hi, Razan this side. Welcome to my YouTube channel. So today we will be discussing the all four problem asked in today's weekly contest 4 to 6. Let's start with the first problem. So the first problem says that you are given a positive number n and you have to return the smallest number x that is greater than or equal to n such that the binary representation of x contain only set bits, right? And a set bit refers to a bit of binary representation of number that has a value of 1. Like set bit means the value that is present at that place is 1, binary 0 and 1, right? So let's see how we can approach this problem. So you are given n and you have to find out the minimum number which is greater than or equals to n and whose bit set, all the bit sets are 1 in its binary representation, right? So let's say the first case. The first case, let's say, if your number itself has all the bit set, then that will be your answer. Otherwise, in the second case, your answer will be, see, if your all the bits are set, it means that this must be in the form of 2 to the power something minus 1, right? If all the bits are set, then the number always be in the form of 2 to the power x minus 1. So let's see how we can approach it. First find k, which is log to the base 2n. Find k. So if n itself is in the form of 2 to the power x minus 1, then n will always be satisfying 2 to the power k minus 1. First find k, then check if your n is already is in the form of 2 to the power k minus 1, then just return your return n. So this will be your answer. Otherwise your answer will be 2 to the power k plus 1 minus 1. The next, like for example, let's say you are given 8, right? For 8 the answer will be 15. So for 8 is 2 to the power so the log value of 8 is 3, right? 3. So your number will be 2 to the power 4 minus 1 extra, which is 15. So it's a straightforward implementation. Let's see how we can write code for it. So this is the code of second problem. What I did, I find the log value, so k is equal to log to the base 2 of n. This is okay. Then I checked if your number itself is in the form of 2 to the power k minus 1, 2 to the power x minus 1, means all bits are set. They return that number itself. Otherwise, return next number who has all bits are set. So that will be power of 2 to the power k plus 1 minus 1, as I already explained in here. That will be 2 to the power k minus 1, k plus 1 minus 1, right? Now let's look at the second problem. Let's see what the problem description says. So it says you are given an integer array nums and this array contains n elements, and out of these n elements n minus 2 are the special numbers, and the two which are remaining, one is outlier and one is the sum of these special numbers, right? So an outlier is defined as the number that is neither the original special numbers nor the number which represent the sum of these numbers, right? Note that the special number, the sum element and the outlier must be distinct indices. So means so like in total you are given n number of elements, right? You have to return the largest possible outliers, right? Let's see how we can approach this problem. So the problem says you are given an array, right? N numbers. Out of these n numbers, n minus 2 are special numbers. Special number. One is the sum of these special number. Sum of these special numbers. And one is outlier, right? Outlier. So let's see how we can approach it. So first find the sum. What is the total sum, right? What is total sum? I claim that sum, let's say the sum of all these numbers are k, right? So you have n minus 2 special number whose sum is k, and this k will also present in the given array as per the problem description. Means that sum must be in the form of 2 times k plus this outlier. outlier, right? Sum will be in the form of 2k plus the outlier. Now what we can do, we will go through each possible numbers in the array. I will check if this can be outlier. If this can be outlier, it means that your sum minus that number must be divisible by 2, right? What I mean, your sum minus outlier is equal to 2k, or I could say your sum minus this outlier will always be divisible by 2. If that is true, so what I'll be doing, I'll go through each possible number in the array. I will assume this number as outlier, then I will check if the total sum minus that outlier is divisible by 2. If that is true, then I will check. So once you do this sum minus outlier divided by 2, that will be your k. I will check if this k is present in the given array. If this k is present in the given array, it means that this is a valid array. A valid array means that you have n minus 2 special array, one sum of these special numbers, and one is outlier, right? So let's see how we can write code for it. So this is the code of second problem. So I initially took the sum of all the numbers in the given array. Then what I did, I took a multiset, because I need to search, right? If you look at the explanation here, you need to search whether this k is present in the given array or not. So to do it efficiently, you can use multiset, because the number could be repeated also. So that's the reason I took multiset. Then so this is your answer. I initialize it, the minimum value, int mean. Then I'm going through all possible number as outlier in the given array. So I will check if my sum minus outlier is divisible by 2 or not, as per the explanation. If that is divisible, this is your k, sum minus outlier divided by 2. Then what I did, I checked if the number k is present in the given multiset or not. But the twist is that you don't have to consider the current outlier, right? This is other than, so once you consider this as outlier, you don't have to consider this outlier as a k. So just remove from the multiset, then check like apart from this outlier, were you able to find any k in the given multiset? If that is true, then you update your answer, and at the end just insert outlier in the multiset to make everything as original as before, and at the end return your answer, right? So yeah, this is the code of second problem. Now let's look at the third problem. So this is the third problem asked in the contest. It's a medium rated problem. Let's see what it says. It says you are given two undirected trees of n and m nodes, right? So all the labels are from 0 to n minus 1 and 0 to m minus 1. Then you are given a 2D array, edges, right? Edges in the form of ai to bi, means there is an edge between ai to bi. So you are given two set of edges, one for the first tree and the second for the second tree, and you are also given an integer k. Now, so like there is a terminology, is called node u is a target node to v if the number of edges in the path from u to v is less than or equal to k, right? Note that the node is always target to itself, because the number of edges between that node to that node itself is 0. So 0 will always be less than or equal to k, so that is always true. So at the end you have to return an integers where answer of I is the maximum possible node target to node I of the first tree if you connect one node of the first tree to this one node to another node of the second tree. Okay, let's see how we can approach this problem. It's a good problem. Let's see how we can approach it. So you are given two tree, right? Let's say this is your first tree and this is your second tree, something like this, right? And this is your tree 1, this is your tree 2, and it says that you have to connect one node from the tree 1 to one node from t2, and at the end you have to find out the answer for each node in tree 1, where answer of I is the number of nodes from that node two other node. So what I mean is, like, if you look at the problem statement, right, this the target node, actually eventually this means that if you have two node u and v, the number of edges between these two are must be less than or equals to k. Then it's a valid v for you, valid target for you, right? So ultimately you have to find out all the nodes which are at a distance of at max k, all the nodes which are at max k distance from you. That's it. Maybe the problem statements is a bit not much clearer to understand, but it says that ultimately you have to find out all the nodes which are at a distance of at most k from the given node. So let's see how. So see, you have to find out the max, right? And easy and all the, like, so for each node you can independently connect a node from tree 1 to tree 2. So what would be the best option? See, let's say this is your node. All the nodes which are at a distance of at most k in t1, you cannot change that. That is a fixed number, right? All the nodes which are at a distance of 0 1 2 0 1 2 3 at most k, that is fixed in tree 1. But for tree 2, in order to get the max node, it's better to connect this node to some other node who has maximum node at a distance of k minus 1. What I'll be doing in t2, for each node I'll be finding how many nodes are there at a distance of k minus 1. So how many number of node at a distance of k minus 1 in t2, in tree 2. So let's say this is so let's say k is equal to 2. So for this, how many number of nodes are at a distance of at most 2? What that node itself, these and this is at a distance of 0, this is at a distance of 1 1 2, right? So there are three number of nodes for this 1 and this and this. So 3, actually this is 4. K is equal to 2, so this will be 4, this and this. For this it is 3, for this it is 1 2 3 4 and 5, so this is 5. For this it is 1 2 3 and 4. For this it is 1 2 3 and 4 and 4. So the max value is 5. So why not connect this node to this node, right? And this is applicable for all the nodes in a T1. For each node I'll be connecting that node to that node in tree 2 who has the maximum nodes at a distance of at most k minus 1. Like, that is the best options you have to get the max value. So yeah, so this is pretty much the solution of this problem. So ultimately what you have to do, you have to find out the nodes which are at a distance of at most k minus 1 in t2, in tree 2, for all the nodes. And for each node, what will be your answer? Your answer of I will be, what is the node at a distance of, at a number of node at a distance of k in t1 plus maximum number of node at a distance of k minus 1 in t2. Yeah, this is your pretty much solution. In t1, find the node at a distance of at most k in tree 1, and here you have to find out the maximum, like the number of node at a distance of k minus 1 in t2, and take the max value, and your answer would be the addition of these two. Yeah, so see, your n is less than or equal to 10 to the power 3, right? So you can do n square complexity. So what I'll be doing, for each node I'll be finding what is the number of node at a distance of k, and here what will be the number of node at a distance of k minus 1, right? So each node, like for each node order of n, and to find the number of node at a distance of k minus 1 for each node, that would again order of n. So total complexity is order of n into n, so which is order of n square. Now let's see how we can write code for it. So this is the code. what I did here, this is your see your edges. So for a tree, if you have n number of nodes in a tree, your number of edges would be n minus 1, right? So your n would be in edges, like the number of edges plus 1 extra. This is your m, this is your m. So then I created the adjacency list of these two tree, adjacency like adz1 and adz2. Then what I am doing here, I created a function, like it's a DFS function. What I'm doing here, I'm trying to find what are those nodes which are at a distance of k, at most k in tree 1. And here what I'm doing, I'm checking what are the number of nodes at a distance of k minus 1 in tree 2, right? And at the end I'm taking the max. What is the maximum number of node at a distance of at most k minus 1 in tree 2? This is your maximum. Then here out what I'm doing, I'm just attaching this node to the max node in the tree 2. Your answer would be good one. So like see, you cannot change it because the number of node at a distance of at most k in tree 1 is fixed. So this is your good one. So good one and good 2 will actually tell you what is the number of node at a distance of k for tree 1 and what is the number of node at a distance of at most k minus 1 in tree 2. So this is your t1 at a distance of k, and this max is the maximum at a distance at most k minus 1 in tree 2. Now let's see what this DSF function says. So if your like current distance is greater than or equals to k, just return, right? So it takes one less. So for k plus 1, once your distance will be greater than or equals to k plus 1, it will be returned, right? Then what I did, I otherwise, so this is your so like if this condition like doesn't hold, it means that you got a node which are at a distance of k minus 1, right? So I incremented the root value. What is the root? So here this is a root. I'm passing root at each point, right? This is a root. So I incremented the root value. Then what I'm doing, I'm doing the DFS for the child node. So now for child node, the distance would be increased by 1, and root is same, k is same, everything is same, right? And this is your I, this is your parent. So now your parent become I and your node become the neighbor. Yeah, so this is the code of third problem. Now let's look at fourth problem. So this is the fourth problem. This is pretty much similar to the second problem. You are given n and m number of nodes, 2 tree, age 1, age 2, where age 1 is ai vi, where and ai is connected to bi, right? Now, so if you remember in the problem 3, we had to find out the number of node at a distance of at most k, but here you have to find out the number of node at a at a even distance for each node in a tree 1. So you have to return an integer answer, where answer of I is the max possible number of node that are targeted to I of the first tree. If you had to connect one node from the first tree to another node in the second tree, right? And target means all the nodes which are at a even distance from the current node, right? So let's see how we can approach it. So here, see, if in tree 1, all the nodes which are at a even distance means like even number of edges, or if you look at it says number of paths from u to b is even, the number of edges. So edges or like number of edges or distance, both are same at a distance of like even distance. So the number of node at a even distance, mn distance in t1 in tree 1, this is a fixed number. You cannot change it. So let's say for this node is at a even distance, and that current node itself is even distance, because the distance here, like the distance from that node to that node itself is 0, which is even. For this is 1. For this is again 0. This is 1 1. So this is a fixed number. You cannot change these the number of node at a even distance in T1. But there is a catch. You can connect this node to one of the node in the T2 such a way you get the max number of node at a even distance in T2. Then so what I'll be doing the same. So like in problem 1, I was calculating the node at a distance of k and k minus 1, right? For this k minus 1. But here what I'll be doing, for each node I'll be calculating how many number of node you have at a odd distance. At odd distance, what is the number of node at a odd distance in T2, and I will connect. Then I will take the maximum. Let's say this is your maximum mx. Mx is the maximum number of odd node for each node. What is the number of node at odd distance for each node? I'll take maximum, and so let's say this is your mx. Then I will connect this to this, because see, eventually you have to find out the node at a even distance. So for this it is already fixed. If I know this is the maximum number of node at a odd distance, if you connect this, then this will become even. Let's say so let's take this example. This is at 0 distance, 1 0 1 1 1. See, for odd it has 1 2 3 4. Once you connect it, all these node become at an even distance from here. See, so at till here it was at odd distance, but once you connect one extra is, now for this all those nodes become even distant, so your answer will be maximized. So now the problem, now you have to find out the number of node at a even distance in T1 plus maximum of number of node at a odd distance in T2. This is your answer, right? So actually the problem, like the thing is, you cannot do brute force, because order of n square won't be accepted. Your n is up to 10 to the power 5, so you have to use dp on tree. So there is a concept called dp on tree, in out dp. So where we find all the node at a distance of even or odd in order of n. So you can use that concept to solve this problem, right? Yeah, so this is all about the solution of all 4 problem. If you find the video helpful, please like, share and subscribe to my channel. Yeah, thanks for watching.